Hello, Homo sapiens. Today, I'm going to tell you how to read the periodic table of elements. So, let's begin. The table is arranged in ascending order of proton numbers. So from the left, we have hydrogen and helium, and then 3 and 4, 5, 6, 7, 8, 9, 10, 11, 12, so on and so forth. And then every column is called a group. And every element on the same group has the same valence electron number or the same charge. For example, an element on group 1 would have only one valence electron. Therefore, its charge is +1. And an element on, let's say, group 5 would have 5 valence electrons. So therefore, its charge would be -3 because 8 or 0 is the desired electron number. From the left, it's group 1, 2, 3, and then skip the middle block of metals because we cannot categorize them into groups. And then 4, 5, 6, 7, 8, 9, just until 8. And that's groups. However, if we look horizontally, we can see each row is known as a period. For periods, each ascending period, like to the right, it will correspond to another electron added to the valence shell, which is quite similar to the groups. It's basically ascending groups. So, let's see how to read one of the boxes in the periodic table. Let's take an example. Helium. Helium has these massive He letters in the center. This is the symbol for helium, He. And the symbol is unique for every other element. Just like oxygen, it's O, uranium, it is U, and thorium, it is TH. It's different for everyone. It's comprised of either just one letter, 2 letters, or 3 letters. If we look to the top left or top right, it depends on your periodic table, but we can see a number without any decimals. And this is the proton number of that element, or the atomic number. And this is also unique for every other element. In the table, it is arranged in ascending order. Hydrogen 1, helium 2, lithium 3, and so on. If we look below everything else, we can see numbers with a decimal or 2. This is the atomic mass, and it's important for calculating moles. Not those moles in chemistry. The atomic mass is also unique for every other element. And for helium, it is 4.002. And this mass is measured in either AMU, atomic mass units, Daltons, named after John Dalton, or just U units. So it's 4.002 Daltons, AMU, U. And there are several sections to the periodic table, such as the noble gases, which I've already mentioned, and to the left of that, we have the halogens, which are a bit more reactive. And then to the left of that, kind of like a triangle, we have the nonmetals, which actually includes hydrogen, all the way on the other side of the table. And then the staircase of metalloids are kind of metal, but also kind of not metal. Yeah. And then the group that contains aluminum, gallium, lead, and bismuth, those are the other metals, which are okay. And then the big block in the center, those are called the transition metals, which transition from the alkali metals to the noble gases. And then to the left of the transition metals, we have the alkaline metals. And then to the left of the alkaline metals, we have the most reactive elements, the alkali metals, which are named alkali metals because when they react with water, it makes the water alkaline. However, what is that island down there? Well, that's the island of the rare earth elements, which can be divided into two, the lanthanides and the actinides. And this is the path you're supposed to read it in because it skips from 57 to 72. 57, 78, 57, 58, 59, continue on to zone 1, zone 2, and continue on. And yeah, you get the pattern. So yeah, that is how to read the periodic table. Thank you.